points and vertex or roots. Okay, I'm getting a lot of questions about this one, and basically, if you're given a point in either the vertex or the roots, derive the equation. Now, people are getting really confused about this one, but if you have a quadratic equation, it is either in standard, vertex, or root form. So, if you're given the vertex, which one do you think you should use? The vertex form. If you're given a root, same thing. Use the root form. In this case, I'm given the vertex. I'll do a root one after this, but I'm given the vertex form and a point. So let's look at the actual vertex equation. There it is in all its glory. Now, you'll see that I left this pretty color-coded because we're going to take all of this information, all of the different colored variables, we have them already. A was purposely left black because that's basically what we're going to solve for. So let's get to it. I know from past lessons that the vertex is always H and K. X is H and K is Y. So let's start logically color coding these things. Now, I know that my vertex is always H and K, and I know that this rando point is just a point on the parabola. It can be literally anywhere that isn't the vertex, and it will still be useful. Basically, you have 2 points of reference at this point. So I'm going to take this, and I'm going to substitute in my y is going to be the y coordinate for this point. So it's going to be the red guy. My x, which is blue, is going to be this 0 here. And now, like we were already saying, h is going to be my right there, and k is going to be the y coordinate of the vertex specifically. Now, these are easy to get mixed up, so if you don't understand yet, don't feel bad, but let's go ahead and plug these bad boys in. Right off the bat, you're going to notice my 5 stays the same as it is up here, my 0 stays the same as it is up here, my k stays the same as it was up here, and the only one that changes is this 4, because even though it says negative h, that does not necessarily mean it's always negative. It means it's opposite. So when I get negative h and my h value is 4, it's going to be negative 4. Now we just got to algebra. So I'm going to 0 minus 4 is 4, and 4 squared is 16. So I'm going to rewrite this. I get 5. It's slowly going to become uncolored as I solve some of these problems. Now I'm going to add 1 to both sides because algebra. And I get 6 equals 16a. I'm going to divide both sides by 16. And boom. A equals 6 divided by 16. In a perfect world, you would reduce that, but honestly, I'm just happy that you got here. We made it. So at the end of the day, our final answer, we are not going to include this point in our final answer. It is a point on the graph. But really, I want my equation to look like this. And equations always have a y and an x, right? I don't want this a, h, or k, but I do want this y and this x. So when I finally write my final answer here, it's going to be y equals 6 divided by 16 times the quantity x minus 4 squared minus 1. Pretty cool, Mr. B. Let's try one that's with the roots. Cool? Here we go again. I've got my roots. I've got my rando point. And now which one should I use? What type of equation should I use? The root equation, duh. So let's write it out. Okay, once again, everything is all color-coded. My A is still black because that is what we're solving for. The biggest difference with this one is that there's two x's, so I need to replace both x's with my x value. So let's start color-coding this bad boy. First off, I know from past lessons that my roots represent my P and my Q, right? So let's do those first. My P, and it really doesn't matter which is which. Obviously, it's not the 0 unless it's 0, 0. But let's just say I always just go with the first one. P is going to be the first one, and Q is going to be the second one. And then, once again, rando point, my x value is in blue, so my rando point value, the x value is going to be in blue. And then y is going to be red. So now we got everything all color-coded. Let's actually plug them in. Okay, they're all in there. Some things I want you to notice. Obviously, y is just 3. That one's easy. A stays the same because we're solving for a. -5 is in there twice because there's two x's. So my x value is going to be -5, but I have to put it in 2 times because there's two x's in this equation. As we know, -p does not necessarily mean that it's always negative. It means that it's opposite what you have up here. Samesies with -q. So when I have a -p and my p is 3, it's going to be x minus 3 right here. But when it's over here, the q, it happens to be -7. It's got to be the opposite of -7. So it's got to be +7. See what we did there? Good. Okay, well, let's algebra. Okay, so I get, this is one of my favorite ones to do just because I feel like the answers end up being a little bit easier to compute. 3 equals A, and now I'm going to do quick multiple. -5 minus 3 is going to give me -8. -5 plus 7 is going to give us +2. I'm going to multiply those. I still have 3 equals A times -16. I'm going to divide both sides by -16. Getting a lot of 16s in these answers. And therefore, I get 3 over 16. I look back, it's negative, which is important. That determines which way the parabola opens up, but that's it. And now I'm going to replace my A here. And just like the last equation, I want to make sure I need to keep my y, I need to keep this x and this x, but I'm going to replace my p, my q, and my a. So let's write out our final answer. It's going to be y equals -3 over 16 times x, minus 3, x plus 7. We did it!